Today I'll be discussing about Set Khas COVID Chapter 2. So let's take a look at this question. Explain why chromium does not obey the alpha principle. So before answering this question, let's take a look of the meaning of alpha principle. So alpha principle states that the electrons fill the lowest energy orbitals first. Lowest energy orbitals first. In ascending energy. Okay, so what does this mean is that the electrons will fill the lowest energy orbital, then to the next energy orbital. Okay, so it will fill the 1s energy orbital, followed by the 2s, followed by 2p, followed by 3s, followed by 3p, and then students tend to do mistake at here. People tend to think that after the 3p orbital, it's the 3d orbital, but they are wrong. It is the 4s orbital, and then followed by 3d orbital. So please keep in mind about this one. Okay, so why does chromium does not obey the alpha principle? That means it has something to do that the electrons does not fill the energy orbitals according to the ascending energy. Okay, so the proton number of the chromium is 24. So let's write the electronic configuration first. So the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d4. But for chromium, this is not the electronic configuration. Why? Because the 3d4 subshell is not stable. It has to be 5. So what happens is that one electron from the 4s orbital will be going to the 3d orbital to make it 3d5. So the actual electronic configuration of chromium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, and 3d5. So you might be asking, why does it need to be 3d5? Why can't it remain 3d4? Because 3d5 is a half-filled subshell. Okay, that means it has extra stability. Okay, this is an anomalous case just for chromium and copper. So in this case, we are looking at the chromium atom. So how to answer this question in sentence form? Okay, there are 4 marks. You can get the first mark by just explaining the alpha principle. So alpha principle states that electrons fill the lowest energy orbitals first, right? Okay, and then to the other orbitals, you must mention in order of ascending energy. Okay, because that is how the electrons fill up. Okay, in order of ascending energy. So students usually forget this sentence, this term right here. Okay, and from there you get the first mark. So how to get your second mark? You can say that the electronic configuration of chromium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. Okay, this one we know as the anomalous case for chromium. Okay, but then you can say that the actual electronic configuration of chromium is supposed to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d4. And then you can say that the anomalous filling of chromium does not obey Aufbau principle due to the half-filled 3D5 subshell to obtain extra stability. Okay, so from here you can see I'm mentioning the electronic configuration of the chromium, the supposed to be electronic configuration of chromium, and why does the chromium does not obey the Aufbau principle. So from here you can get the second mark, the third mark, and the fourth mark. So it's an easy score. Let's take a look at the next question, 2b. Why 2 plus ions, okay, they said ions has 2, 8, and 10 electrons in principal quantum number n equals to 1, 2, and 3. That means there are 3 shells, okay, filled with these electrons. Determine the atomic number of Y. So atomic number is the same as proton number. Okay, they say of Y. So only Y, it means atom. Okay, the original state. Okay, from the ions you can get Y2 plus ions has electrons of 2 plus 8 plus 10. Okay, you get a value of 20. So this is the total electrons for Y2 plus ions. Okay, Y ion. So how does it become ion? So Y atom will donate 2 electrons. Okay, always take a look of this 2 plus. 2 plus means the atom has donated. Okay, students tend to do mistake at that, so keep in mind 2 plus means, okay, plus means donated, negative means receive. So Y atom donates 2 electrons to become Y2 plus ions. So to write the electronic configuration of Y atom, okay, so when I write Y atom, that means there are 22. Okay, if I write electronic configuration of Y2 plus, there will be 20 Y2 plus ions. So ions to atom, the original one is 22, the proton number. Okay, so you have to write the electronic configuration of the Y atom to show how you get the atomic number of Y. So you write 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d2. In Y2 plus ion, the 3d2 won't be there. But since this is an atom and it has donated 2 electrons, so 3d2 subshell will be there for Y atom. So the atomic number of Y will simply be 20, okay, from the total ions, plus 2, the original proton number, which is 22. Okay, so the mark distribution is at here. The first mark, the second mark from the electronic configuration of Y atom, and the third mark to show the atomic number of Y. So let's do the next question, 2c. An electron in hydrogen atom is excited to n equals 5 energy level after it absorbs a photon of 2.09 times 10 to the power of negative 18 joules. So this is actually the energy of photon, and the energy of photon is equals to the energy difference, which is equals to the final energy minus the initial energy. Keep in mind of this information always. Okay, so let's have a look of C1. Okay, to C1. Calculate the energy of this electron. So they mean the n equals 5. Okay, they specifically say of this electron only. So there's no difference, nothing in there. Okay, so n equals to 5. And always remember to write the formula over n square. So this is the formula. Okay, always remember to write it. Okay, now you just start in. So the Rydberg constant is provided times 10 to the power of negative 18, 1 over 5 square. The n here represents the energy level. Okay, so when you calculate it, you will get the value of negative 8.72 times 10 to the power of negative 20. If you leave your answer at that, you won't get any marks because you have to write the unit joule. Okay, when you write the unit joule, that's when you will get a mark. Okay, also you have to remember that this is the final energy, so it's EF because it is excited to n equals to 5 energy level. Okay, so the next question says that we need to determine the initial energy level of this electron, so the Ni. But before that, we don't have the initial energy, but we can find it as we have the final energy and the difference in energy. Okay, difference in energy equals to the final energy minus the initial energy. The initial energy will be the final energy minus difference in energy. So just sub in with the values you have, negative 8.72 times 10 to the power of negative 20 minus 2.09 times 10 to the power of negative 18. So the initial energy will be negative 2.1772 times 10 to the power of negative 18 joules. Always remember to put the unit. Okay, so now that we have the initial energy, we can find the initial energy level, the Ni. So write down your formula again. Always remember to write down the formula when you're substituting any values. Okay, so the formula is very important as well. Don't forget to write it down. So next, you substitute with the values you have already, times that of negative 18, the Rydberg constant, okay, 1 over Ni square. So 1 over Ni square is to 5443 over 5450. Ni square equals to 5450 over 5443. So the initial energy level will be 1. So this is the final answer. Okay, I have to remember that sometimes students forget to put the square during the calculation, and for the Rydberg constant there will be two different values. So which values to use? Okay, there is one with 1.097 times 10 to the power of 7 meter per meter, sorry, and another one is 2.18 times 10 power of negative 18 joules. So how do we know which one to use? So this one we will use to find the wavelengths or the energy levels, okay, for two different energy levels, where the N1 will be lesser than N2. And for the second one, since there is a joule, we use this to find difference in energy or initial energy or final energy, anything related to that. So always keep in mind to use the suitable Rydberg constant for this specific question, depending on the question. Alright, so I hope you understand. Thanks for watching.